All right, this is the new topic that we really want to take a look at today, and that is everything you wanted to know and then some with regards to springs. Just a bit of an introduction today. There's going to be no assignment associated with this. Okay, well, I'm probably lying there. There might be a couple small questions, but it'll be pretty small. And of course, it's not a bad thing to know about springs at least a little bit. Every time you give something a push and it rebounds back to its original position, or you give something a pull and it rebounds back to its initial position, there's probably a spring in there somewhere. Like for example, if you take a close look at a ballpoint pen, there's a spring in there somewhere. Think of your computer keyboard. Okay? You push a key down, it pops back up. There's a spring in there somewhere. It might not be your typical classic metal spring. It might be a piece of rubber, but it's behaving like a spring nonetheless. Probably the best example of springs at work is inside a vehicle suspension system. There's a multi-million-dollar industry, and of course, what does a spring inside a vehicle suspension system do? Well, it takes the vehicle after it goes over a bump and it brings it back to its original position. Okay, so if you're going to look at springs, for starters, what are you going to do? Well, first we should talk about a little bit of basic terminology, I guess. Here is your basic spring. Right here, let you get a little closer look at that. And if I hang the spring there and I apply force to it, of course, it stretches. Okay, now let's stop it bouncing. Okay. Let's try that again. This time, let's be a little more scientific about it. Okay, so where the spring is right now, there's no force on it. That's called its equilibrium position. And if we apply a force to the spring, well, however much the spring stretches, that's what physicists like to call the spring's displacement. Okay? The amount the spring moves from its equilibrium or unloaded position is called the spring's displacement. And for whatever reason, I don't know why, but when physicists talk about a spring's displacement, sometimes they abbreviate with a delta x, which they probably should, but lots of times, if they're talking about a spring's displacement, okay, they just abbreviate that with the letter x. Okay, now, if we were in class, okay, we would get you to do a lab using a couple different springs. And we'll let you take a closer look at these two springs. And you can see if you look closely, I'll try and hold them steady there. If you look closely, the diameter of the wire used to make one spring is significantly thicker than the diameter of the wire used to make the other spring. So I've got a little thicker spring on here first, and if you were to do this lab in class, well, you would apply different amounts of force to it and see how much the spring stretches in each case. And you would do that with one spring. That was the thicker one. Here comes a skinnier one. And then you do it with the other spring. And you can see that the skinnier one, well, yeah, same amount of force obviously makes a skinnier one stretch more, or makes it undergo a bigger displacement. Okay, now that's a great lab to do during period 6 in the physics lab, you know, it's a little bit like decorating a Christmas tree, but you're at home, it's probably a little harder to get motivated to do these these very precise measurements of how much the spring is being displaced each time. So instead of doing the lab like this, we're going to do a quick and dirty version of it. A physicist would say that we're going to do a more elegant version of the lab. Okay. Oh, and one thing to keep in mind when we're experimenting with springs here, what we want the springs to undergo is elastic deformation. In other words, when you apply a force to them, they bounce back to the way they originally were. We do not want the springs to undergo plastic deformation. Okay. And that, of course, is plastic deformation. The spring undergoes a displacement and it does not bounce back. Regardless, I'm going to cut away for a sec and I'm going to be back with the apparatus that we're going to use to do the slimmed down, streamlined version of this lab. Alright, so here's how we're going to do a quick and dirty version of a springs lab. We are going to use a spring scale, and you can imagine why a spring scale is called a spring scale, because at the heart of them is a spring, and of course the more force you put on the scale, well, the more the spring stretches. And the advantage of using a spring scale like this is that if you lay a ruler down beside one, the markings there, they already tell you exactly how far the spring is being displaced when a certain force is applied. You know, if I apply 2 newtons of force, I can see the displacement is about 0.6 centimeters. If I apply 8 newtons of force, I can see the displacement is about 2.3 centimeters. And of course, you don't have to apply the force at all. You can just take a look at the face of the scale, okay, and make your measurements with regards to how much the various forces displace a spring. So for this lab, what I'm going to do is I'm going to take a picture, a still photograph of this spring scale with a ruler laid alongside it. I'm going to take a picture of this spring scale with a ruler laid alongside it, and then I'll post a PDF as well, and the PDF will basically show some calculations and come up with a couple graphs without having to play around with this bit of high-tech apparatus that's held together with Funtac. Bye for now.